So the next step is to specify what this get input does. Well, get input needs to be defined as a method. It needs to be static at this point. I can say maybe it's a private static method. It needs to return back a double value. Double value. And the name, we already invented the name, get user input. And get user input takes string as a parameter. And we'll say prompt, right? Because we want this to control. So we'll have a couple of versions of this today. First version of it might look like this. Well, obviously, I need some sort of a scanner. Scanner sc equals new scanner. New scanner system dot in. So that's fine. Then, of course, again, I can do my trick to say fix imports, which simply, uses available Java API classes. So now I can say, well, I can display the prompt system dot out dot print the prompt, right? So I can print that prompt. And finally, I can say double temporary value, double temp equals scanner next double, right? Because there is the next double method provided by the scanner, which will extract the next double value. And then I can say return temp. Well, of course, I can compile and run it, but the problem is that if I do something bad here, it will crash. In fact, let's establish this. Type your amount. Oh, by the way, so let's fix this. Let me actually close this running program. I don't like the way it prints, so I need like maybe a colon and a space to make the white space visible between the prompt and the user input. So let's try this again. All right, type your amount. All right, 123.45. Then it works fine. Run again. So this time, type some garbage and hit enter. And this is what we're talking about, is that when the runtime error occurs, what happens is that some sort of an exception is produced as a result of program execution. In this case, this is input mismatch exception. This is a data type, an actual object, which is instantiated as a result of this. And what a default exception handler in Java Virtual Machine does is that it prints this stack trace for us. Basically, it tells us that starting in main Java, line 23, you can see where that is. Line 23 is right here. And starting from here, what took place was that, actually I need to display my output, right? What took place is that the main method right here made a call, and I'm trying to interpret this line 23. The story went on, and when this call was made, get user input was invoked. And in there, on line 13, now in get user input, during this call, of course, when the call takes place, the life in main is frozen, right? Nothing is taking place. We're waiting for this call to return. So the method executes, goes as far as line 13, and then it says that the output tells us that on line 13, apparently, there was the next double call taking place. There was scanner.java class that was invoked, and apparently it did next double, and it did next, and then they did the throw of some sort, and eventually from this point on, an exception was created and thrown. And this all resulted in such outcome that get user input did not succeed. It never finished. The program never finished. The program never returned from this call. And the program crashed, but just before the crash, will sort of crash intentionally, right? It was by design, because the scanner get double or next double is designed to stop the execution, the normal flow of execution, unless the proper input is found in the input buffer, in that input that was processed. So the question is, how do we deal with this, and how we can make it durable, and try to work with this. So if this is the case, now again, so if where's my output window? Did I close it? View. Where's my output window here? Debug. Or somewhere here in this menu, there's a way to display here, maybe output. Yeah, I want to bring it back. All right. So I already know from this stack trace, this is called the stack trace. Typically, the origination code is at the bottom, and when it went all the way up, and at some point it ended. So I can press Control-C to copy this and say, well, you know what? I am going to say try this, opening brace, and then the closing brace, and then say catch. And the result of that catch will be something that I call input mismatch exception. I will name this object EX, and this is how I am going to deal with it. One little thing is that now that I added this try and catch block, the creation of the local temp variable now has to take place before this try and catch block, because any set of braces like this one establishes its own little scope. However, I need this variable outside of the scope, so perhaps I can do something like this. Just say temp equals, but before I do it, create double temp variable. I may even initialize it to 0.0, but not required, right? So in case if I catch the exception, then I will print again something, right? So I will print, this time I will print bad input format, and I can use like 3 asterisks here, then the tab to shift this bad input format, comma, try again, right? And this could go on the separate line, something like that. And to try again, I need to keep user in this loop. So in this loop, I can have this endless loop right here, starting with try and catch, just forever, right? Forever loop. I can say, okay, let me have a forever loop, and do this in the loop. Control X, Control V. Essentially, you can select this, press Tab, and format it, indent it nicely. So now I have an endless loop. This is the end of this endless loop. But I really, oh, by the way, return at the end. Sorry about that. And if this succeeded, then I can say break. I can say break. Now, notice something interesting. If I didn't have a break, the program would not compile, because Java compiler would understand that this is an endless loop. There is a try and catch inside this endless loop. So try this particular statement in our case. If an exception takes place, then you can catch this exception. And you can say bad input format, and then you're going to loop again. But if this succeeds and there is no exception produced, then Java realized that we're going to create this endless loop indeed and never exit it. And therefore, this return statement is unreachable. So if you try to compile it, the error will be unreachable statement. Right? So that's why, you really need to provide the means to somehow exit this, in logical manner, exit this loop. Okay, so let's save this.